the third prong on an electrical plug is not sufficient for grounding in a data center environment for several reasons. Firstly, the increased risk of electrical hazards is a significant concern. While the third prong provides a connection to ground, its primary intention is for protection against electrical shocks. In a data center, where high-powered equipment is present, a solid grounding system is essential to mitigate the risk of short circuits, fires, and other electrical hazards. Secondly, there is the limited current carrying capacity of the third prong. The third prong is typically rated for a maximum current of 15 amps. In a data center, equipment racks may contain multiple servers and other devices, which can draw significant amounts of current. Relying solely on the third prong could result in an overload, which could compromise the grounding system. Thirdly, the potential for ground loops exists. The use of the third prong as the sole grounding path can create ground loops, which occur when there are multiple paths for current to flow between equipment and ground. This can introduce noise and interference into sensitive electronic equipment. NEC 250.112d specifically excludes third prongs for equipment enclosures. NEC 250.112d states that third prongs on equipment plugs are not sufficient for grounding equipment enclosures. In a data center, the equipment racks are considered enclosures and must be properly bonded to ground. The best practices for grounding in a data center can be highlighted. According to NEC 645.15 and other industry best practices, the following steps should be taken for grounding in a data center. 1. Ground all exposed non-current carrying metallic parts of the rack to a reliable grounding electrode system using a solid copper wire of the appropriate size. 2. Bond the cases of all equipment to the rack using a separate bonding wire. And 3. Ensure that all power outlets and plugs have a proper third prong for shock protection. By following these best practices, a safe and reliable grounding system can be created in your data center, reducing the risk of electrical hazards and ensuring optimal performance of the equipment. Now let's delve deeper into each of these aspects, expanding on the reasoning and providing a more comprehensive understanding of data center grounding. Firstly, let's consider the increased risk of electrical hazards in more detail. Data centers are environments densely packed with electronic equipment, each drawing significant power. The potential for faults and failures is ever present. A robust grounding system serves as a critical safety net, providing a low impedance path for fault current to flow back to the source. This rapid flow of current triggers protective devices like circuit breakers, quickly interrupting the power supply and preventing dangerous situations like electrical fires or equipment damage. If reliance is solely on the third prong of the electrical plug, the limited capacity and potential for impedance can delay or impede the clearing of a fault, increasing the risk of a hazardous event. The solid grounding system ensures a swift and decisive response to electrical faults. Secondly, let's explore the limited current carrying capacity of the third prong. While a standard 15 amp circuit may seem adequate, consider the cumulative current draw of multiple devices within a single equipment rack. Servers, storage arrays, networking gear, and other components all contribute to the overall load. In many cases, a single rack can easily exceed 15 amps, particularly during peak operation. Over-reliance on the third prong for grounding can lead to overheating of the grounding conductor, potentially melting insulation and creating a fire hazard. A dedicated grounding system, utilizing appropriately sized conductors, provides ample capacity to handle fault currents safely and reliably. Furthermore, a properly engineered grounding system distributes the current load more evenly, minimizing stress on individual components. Thirdly, let's examine the potential for ground loops and their detrimental effects. Ground loops occur when multiple paths to ground exist, creating a closed circuit through which current can flow. This circulating current can introduce unwanted noise and interference into sensitive electronic equipment, disrupting data transmission, causing errors, and even damaging components. The third prong on multiple devices connected to the same rack can inadvertently create these ground loops. By bonding all equipment cases to a common grounding point within the rack, a single, low-impedance path to ground is established, preventing the formation of ground loops and minimizing the risk of noise and interference. Fourthly, let's discuss why NEC 250.112d specifically excludes third prongs for grounding equipment enclosures. The National Electrical Code recognizes the importance of robust grounding for equipment enclosures, particularly in environments like data centers where safety and reliability are paramount. Equipment racks are considered enclosures, and as such, they must be properly bonded to ground using dedicated grounding conductors. The third prong on an equipment plug is not considered an adequate substitute for this dedicated grounding connection. The NEC mandates this requirement to ensure that enclosures are effectively grounded, providing a safe and reliable path for fault current to flow. Therefore, the best practices for data center grounding should be explored in more detail. Firstly, grounding all exposed non-current carrying metallic parts of the rack to a reliable grounding electrode system is crucial. This involves connecting the rack to the building's grounding electrode system using a solid copper wire of appropriate size, as determined by the NEC. This connection provides a direct and low impedance path to ground, ensuring that any fault current is quickly and safely dissipated. The size of the grounding conductor must be carefully selected based on the size of the power conductors serving the rack, as specified in the NEC. Secondly, bonding the cases of all equipment to the rack using a separate bonding wire is essential. This creates a common ground plane within the rack, minimizing voltage differences between equipment cases and preventing the formation of ground loops. The bonding wire should be sized appropriately and securely connected to each piece of equipment. Thirdly, ensuring that all power outlets and plugs have a proper third prong for shock protection is still important. While the third prong is not sufficient for grounding the entire rack, it still provides a valuable layer of protection against electrical shock. This third prong should be properly connected to the building's grounding system. By adhering to these best practices and complying with the NEC requirements, data center operators can create a safe and reliable grounding system that protects equipment, personnel, and data. It's essential to remember that grounding is not a one-size-fits-all solution. The specific grounding requirements for a data center will depend on several factors, including the size of the facility, the type of equipment installed, and the local electrical codes. It's always recommended to consult with a qualified electrical engineer to design and implement a grounding system that meets the specific needs of your data center. Now, let's further elaborate on the grounding electrode system and its role in data center grounding. The grounding electrode system is the foundation of a data center's grounding infrastructure. It provides a connection to the earth, allowing fault current to safely dissipate. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes that are buried in the earth. The NEC specifies the requirements for grounding electrode systems, including the minimum size and number of electrodes required. The grounding electrode system must be properly installed and maintained to ensure its effectiveness. Regular inspections should be conducted to verify that the electrodes are in good condition and that the connections are secure. In addition to the grounding electrode system, the data center's grounding infrastructure should also include a grounding busbar. The grounding busbar is a copper bar that serves as a central point for all grounding connections within the data center. All equipment racks, power distribution units, and other electrical equipment should be connected to the grounding busbar. The grounding busbar should be connected to the grounding electrode system using a dedicated grounding conductor. The grounding busbar helps to ensure that all equipment within the data center is properly grounded, minimizing the risk of electrical hazards. Another important aspect of data center grounding is the use of isolated ground receptacles. Isolated ground receptacles are designed to minimize noise and interference in sensitive electronic equipment. These receptacles have a separate grounding conductor that is isolated from the building's normal grounding system. This isolated grounding conductor provides a clean and dedicated path to ground for sensitive equipment, reducing the risk of noise and interference. While isolated ground receptacles can be beneficial, it's important to use them sparingly and only where necessary. Overuse of isolated ground receptacles can create ground loops and other problems. It's also important to ensure that the isolated grounding conductor is properly connected to the grounding busbar and the grounding electrode system. Furthermore, it's important to address the topic of transient voltage surge suppression, also known as TVSS. Transient voltage surges are brief spikes in voltage that can damage or destroy electronic equipment. These surges can be caused by lightning strikes, power grid switching, or other events. TVSS devices are designed to protect equipment from these surges by diverting the excess voltage to ground. TVSS devices should be installed at the service entrance of the data center and at each equipment rack. The TVSS devices should be properly sized and rated for the voltage and current requirements of the equipment being protected. It's also important to regularly inspect and test the TVSS devices to ensure that they are functioning properly. In summary, a comprehensive data center grounding system is essential for ensuring the safety and reliability of equipment and personnel. The grounding system should comply with the NEC and other applicable standards. The system should include a grounding electrode system, a grounding busbar, dedicated grounding conductors, isolated ground receptacles, and TVSS devices. Regular inspections and maintenance should be performed to ensure that the grounding system is functioning properly. By following these guidelines, data center operators can create a safe and reliable grounding system that protects their investment and ensures the continued operation of their critical infrastructure. Also, grounding and bonding are often used interchangeably, but they are distinct concepts. Grounding refers to connecting electrical equipment to the earth, providing a path for fault current to flow. Bonding refers to connecting different metallic parts of the electrical system together, creating a common ground plane. Both grounding and bonding are essential for electrical safety. Bonding helps to minimize voltage differences between different parts of the electrical system, reducing the risk of electrical shock. In addition, regular testing of the data center grounding system is paramount. Regular testing should be conducted to verify that the grounding system is functioning properly. Testing should include visual inspections, continuity tests, and impedance measurements. Visual inspections should be performed to check for any signs of damage or corrosion. Continuity tests should be performed to verify that all grounding connections are intact. Impedance measurements should be performed to measure the resistance of the grounding path. If any problems are found during testing, they should be corrected immediately. Poor grounding practices can have serious consequences, including electrical shock, equipment damage, and data loss. It's essential to take grounding seriously and to follow best practices to ensure the safety and reliability of the data center. Finally, documentation of the data center grounding system is often overlooked. Proper documentation of the grounding system is essential for maintenance and troubleshooting. The documentation should include a diagram of the grounding system, a list of all grounding connections, and the results of all grounding tests. The documentation should be kept in a safe place and should be readily available to maintenance personnel. So, in conclusion, remember the third prong is not the answer to grounding servers and racks. It is a multifaceted approach.